Hi everybody, we're back today for some more maths. Yay! And as you can see quite right from the screen, this is for GCSE Maths Higher students. So if you're just doing foundation and you don't want to do anything, have anything to do with higher, you can skip to one of the videos further down below or to the right there, on frequency polygons, etc., which is also on for this week. So if you want to do that, you can stop watching this now. However, if you're curious or want to know if you could stretch your brain to GCSE Higher, you can continue on and watch on, because an awful lot of you just don't have to make your mind up about which one you're going to choose yet. So, with that in mind, what are we doing today? We are doing Ye Old Histogram. That's not actually the title of it. It's just one that I made up because I'm feeling like we're just a week removed from International Talk Like a Parrot Day. So I've been talking like this here for a week. Not really, but I thought it would inject a bit more of an interest into it. And I should say this lesson has been repurposed from the TES website, Owen134866. I'm going to stick a link down to his stuff down there because I really thought this was very, very good. Why reinvent the wheel when somebody's already done it quite well? So what is a histogram and what makes it different from a bar chart or frequency polygon or any of the other things we've already looked at some stage in the past? Continue on. We're going to start with an example. So we have it says to draw a bar chart to show the following information. So this could be the height of people within a class, for instance. So the height measured in centimeters between 100 and 120, 120, 140, 140, 150, 150, 160, etc., etc. And the frequency is the number of people that represented. A couple of things to point out here. First thing is this is continuous data, and because it's continuous data, you can see the bits that I've highlighted here. Because it's continuous data is measured, we have to cover all eventualities from one to the other. So if somebody measured, say, 120.0001, there would have to be somewhere to put that in. And if we just didn't put these greater than, less than or equal to signs in, then we would get lost there. Because if it was 120.00001, where would he fall into? There's two 120s there. So we'll have to be careful. The top one is everything up to and including the number 120, and the second one here is anything from 120 up and to and including 140. So that one that I mentioned, 120.0001, would fall into this bracket here. Okay, that's the first thing to notice. The second thing to notice is that the class intervals, or the ranges of each category here, are different. Now it starts off looking the same because there's roughly 20 there, there's 20 there, this one's 10, this one's 10, and this one's 40. And this is going to create some problems because when we come to plot this as so, as you can see, it's set up exactly the way you would think. So you've 100, 120, 140, 160, 180, etc., etc., etc. on the bottom, and then your frequency up the side. And if I draw my bars in, the first one will go in roughly there. So it goes up to 20, and the next one's 25. The next one's 30. The next one's 25, and the next one's 20. Now, can you spot any problems with this method of doing a bar graph? No. Well, I'm going to point some out to you. Data is continuous, so there shouldn't be any gaps, and in a bar chart you have to have gaps. It's not a bar chart if it has no gaps. So there has to be gaps in a bar chart, and because it's continuous there shouldn't be any gaps. This little bit in here shouldn't exist. There's no category or weight or height in this case that isn't covered by your graph, so that's one problem. 150 to 160, which is this bar here, has the same height as this one, even though it represents a smaller range of people. Okay, it's another one. And the third one is, the third point I should make is a histogram will correct both of these problems. So in histograms, we do exactly the same thing, but we introduce a concept called frequency density. And what this does is take the width of the range of that class interval or this category into account, as well as the frequency. This might be getting a wee bit scary at the moment, right? But like most things in maths, once we do a couple of examples, etc., you'll get into the way of what we're doing. Remember what it's for. This is in this case is representing frequency data, or sorry, continuous data, which has different sizes or different widths of categories. Like if you were grouping categories beforehand and putting them in a bar chart, they would all be equal. So when we were doing questioning, for instance, and approving questions, if the excuse me, if the category widths weren't the same size, then we couldn't draw a bar chart to satisfy that. Okay, so with that in mind, we do this frequency density. And how do we work out frequency density? Well, it's quite simple. It's the frequency on the top, in this case 20, divided by the class width. And the class width is exactly how wide this is. So what do we get if we go from 100 to 120? Or what's the difference between those two values? Well, it's 20 in this case. So in the first one, the frequency density is 20 divided by 20. And that would give me 1. So in our frequency density column would go 1. What about the next one? In the next one, our frequency is 25, as you can see here. And our class width is 140 minus 120, which is 20. If we do that, it gives us 1.25. And if I continue on with the rest one, we'll have 30 divided by 10, which is 3. This one will have 25 divided by 10, which is 2.5. And this one will have 20 divided by 40, which you can do in your head, and you get 0.5. And there is our new table put in. So like other bits that we've done, like frequency polygons, you would create an extra column or two on the right and fill in the prerequisite information. So what you're going to plot is actually your height against your frequency density. Okay, and it looks something like this. So you would still set up along the bottom of your graph, you know, your equally spaced heights. So 100, 110, 120, 130, 140, 150, 160, etc. etc. But up the left hand side you would put your frequency density. Okay, and what we would plot would be something like this. So our first one, 100 and 120, would be use the whole width from there to there, but because it is a frequency density, it'll only go up to 1, and your bar will look like that. The next one will start directly afterwards, so no gaps in here, and we'll go from 120 to 140, and it'll go up to 1.25. The next one will have a gap of 10 just going along here, but we'll go up to 3, as so. Similarly for the next one, it's going to go to 2.5, and the last one's going to go to 0.5, and it would encompass whatever width we're talking about. Now, why is this better than what we were doing beforehand? Well, the reason that it's better is that it takes the width of the class in. There's a higher density of people that fall into this range here than there are in here. So while there might be 20 people fall within this range here, that's spread over a really large space. And if we were just to look at that as a bar chart, you wouldn't get the feeling, or you wouldn't represent that, you know, if we're talking about that as a category or a subset, you know, there's not actually that many people that fall into there. Most people are more densely populated in this area here. And we'll still continue to contain most of the data. What we would find, what if we'd done 140 to 160? Well, we would have had 55 people in there, and it would have been way up. But in this case, we've maintained some of the data integrity, if you know what I mean. We know that 140 to 150 is more popular than the 150 to 160, and that's important. So, with a histogram, the important thing to realize, and one of the key points, is we've plotted frequency density against the height. The area of the shape represents the frequency, not the height. If you think in a bar chart, the height tells you the frequency. In a histogram, the area is the frequency. We've plotted frequency density against height. That's a very, very key difference. This first group here, the frequency is, we've got a width of 20 measured by 1, so the frequency is 20 multiplied by 1, which is 20. And if I click back to our thing, you can see that that is indeed correct. So for that area there, or for that class width or class interval, it's going to be a frequency of 20, which definitely holds true. Like there. So the 20 people in this group. If I do the fifth group, this big one here, it measures 40 by 0.5, and so the says there are 20 people in that group and the frequency is 20 for that group. Okay, so if we do another one, we're going to take into account the size of the group. We have a frequency of 10 and a class width of 40, 0 to 40. So it'll be 10 divided by 40 is 0.25. Now I've got the first one. Pause the video. See if you can work out what the rest are. And then come back and I'll take you through to see if you got it right. Okay, with that in mind, let's see. The next one's 15. And the class width is 10. 50 minus 40. So that gives us 1.5. Next one, we have 18 over 10, which is 1.8. We have 20. The class width of the next one is 65, take away 60, which is 5. So we have 20 over 5, which is 4. And the next one, we have 35 over 5, which is 7. And the last one, we have 20 over 10, which is 2. Did you get those right? That you did. If you didn't, rewind it back to the bit earlier in the video and see what you come up with. So how do we plot that? We've got our frequency density up the side, we've got our speed along the bottom on the right, and it's always your frequency density up the left, if you know what I mean. So the first one, with this big area of 0 to 40, with the really low density of people. There are only 10 people said it, and so it's 0.25. Next one's 1.5 for this gap of 10. Then we've 1.8 for the next gap. And then we've got two smaller class intervals of 5, and you'll see that the density of both goes way up very quickly before falling back down to its normal bit from beforehand. So again, in this area where most of the people were clumped up, we've kept the integrity of that. Right, if we had done the whole 10 and everybody had fallen in, we would have known that was the most popular, certainly. But we get to know that we're actually 60 to 70s nearly twice as popular as what 60 to 70 is. And so we haven't needed to plot a bar like the wee tiny bars a way along, and then have big massive bars. We can contain the space of our chart a bit better, so it's better proportioned. Okay. So remember that area represents the frequency. So if I was working out group 1, it's a 40 by 0.25 triangle, and that would give us a frequency of 10. So there's 10 people in this group. Group of 5 is a 5 by 7, which is that one, and that gives you 35. It's just 35 people in this group. And you're probably wondering, well, we know that because we plotted the graph, but what if you were given the graph and asked to interpret it? And we're going to come on to that very, very shortly. Let's do a worked example that's from a past paper. So a table shows information about the size of eggs and percentages of eggs sold in a supermarket in the UK. So along the top here we have our classifications of the eggs, both in size, so small, medium, large, extra large, and we have the minimum weight, with the maximum weight, and the percentage of eggs that they sold in a supermarket. Now the first bit of information it gives you, you may assume no eggs are less than 33 and or more than 103. So these two bits that are dashed out, we can now fill in. We have to draw a fully labelled histogram to show the data. So the first thing we should do is put in that the smallest size that can be is 33 and the biggest size that can be is 103. And this will let us work out our class intervals. So our frequency density when calculating it, remember, is our frequency, which in this case is 10, divided by our class interval, which is 53, take away 33, which is 20. So it's 10 over 20, which is 0.5. Similarly, the next one is 22 over 10, which is 2.2. With 53 over 10, which is 5.3. And the last one with 15 over 103 minus 73, which is 30. 15 over 30 is 0.5 again. And voila, we get our histogram to look like this. Remembering we have our weights along the bottom in equal intervals 30, 40, 50, 60, 70, 80, 90, 100, and 110. They have used the squiggle line to cut out the 20 and the 10. In this case, I don't really think there was any need. On this, it depends on the size of your graph paper. And we've got our frequency density along the side, and there's our fully labelled histogram. So I hope that was helpful for an introduction. In the next part, we're gonna look at how we interpret histograms that we've been given, and we'll see how we get on. But I'll just summarize this lesson. So we've learned how to plot histograms of sets of data. We've learned how they're different to bar charts, and we've learned what is meant by the term frequency density. Remember, it's the frequency divided by class width. We've shown that on a histogram, area represents the frequency, not the height, which is what happens in bar charts. Okay, we're back after that nice introduction to histograms, and we're going to come and look at the second part, which is ye old histograms interpreted. And I'm going to drop the parrot voice because it was slightly unbecoming of me. But yeah, let's interpret some histograms. Okay, so introduction to it again. We're going to draw a histogram to show the following information on the time taken to do a crossword. So, not the 60 seconds, there were 30 people, 60 to 120, there's 90, etc., etc. And you can see the table there on the right. So, remember, the first step that we need to do is work out, add another column to the right, this frequency density column right here. And we need to work out the frequency density. And that was the frequency divided by the size of the class width, which is the difference between the upper and lower bounds of the interval here, or the category. So 60 take away naught, so it's 30 divided by 60 over naught, 30 over 60. If you put that in the calculator, it goes 0.5. And it is bears in mind that this does fall under the remit of the calculator paper. Second one is 90 over 120 minus 60, so it's 90 over 60, which is 1.5. Then we'll have 140 over 20, which is 7. We'll have 180 over the 20, which is 9. And that's what nice with 160 over the difference of 240 and 160, which is 80. So 160 over 80 is 2. And so we have our frequency density here, and we'll have our class intervals down the side here. And when we're plotting those, it looks something like this. So our frequency density up the side and our seconds along the bottom. Our frequency density will go up the left in regular intervals, and our seconds along the bottom will go along in regular intervals as well. And so our first bar, not the 60, will go up as far as 0.5. Our second bar that goes 60 to 120 goes up as far as 1.5. The next one's an awful lot slimmer because it's only equates for 20, goes up to 7. Another slim bar up to 9, and then the last big section at the end is there. So that's us drawn. And always remember that the area of the bar represents the frequency in histogram. Remember, this is the frequency density up the side. It's not the frequency. The frequency is the area of that bar. Okay. So the fourth group in the rectangle, this big tally one, the tallest one, is 20 wide and 9 high. So the frequency of that is going to be 20 times 9, which is 180, or 180 people in this case. But what if you were asked, estimate the number of people who took between 30 and 90 seconds to complete the test? What would you do? Okay, you'd go from your 30 point to your 90 point and see what the area under the graph is. So we've basically got two bits here, part 1 rectangle, and it will measure 30 to 60 is the width here by 0.5. So it's 0.5 by 30, and that will give you 15 people. Part 2 is the space from 60 to 90, so again it's 30 by the frequency density, which is 1.5, which is going to be 45. So estimating the number of people who took between 30 and 90 is going to be the 15 plus the 45, which is going to be 60 people. Quite easy as long as you know what you're doing, and as long as you know that the area of those bars is the frequency, then you're good to go. What about in this one? Here's a histogram that's been drawn with frequency, density and speed along the other axis. We've to use the histogram to complete the table, so it's a bit like in reverse. So 0 to 20, 20 to 50, 50 to 60, 60 to 70 and 70 to 90. So we'll do this in reverse. So we know that the frequency density, this is the class width, is what you get when you take the frequency and divide it by the class width. So if I rearrange that formally, you would get that frequency is the class width times the frequency density. So if the class width for the first one is 20, then I multiply by the things and that by the frequency density, and that would give me 40. What about the second one? The class width is 30 and the height 6. So the frequency is going to be 30 times 6, which is 180. Excuse me. Next one is going to be 10 times 8, which is 80. Remember that the width of that is 10, the height of that is 8, so it's going to be 80. Next one is going to be 10 times 5, which is 50. And last but not least, we have 20 times 1 is going to be 20. And there is your original table filled out just by being given the histogram itself. Estimate, next one, estimate the number of people whose average speed was 10 to 40 miles an hour. So we're going to have a line at our 10 and a line at our 40, here and here, and we're going to have to work out the area underneath these two bits, which would give us the frequency. So in the first one, rectangle 1, which is that one, we've got a width of 10 and a height of 2. So if I do 10 times 2, it gives me 20. Similarly, in the next rectangle, rectangle 2, it's a width of 20, which is 20 to 40, multiplied by 6. And that's 120. So if I'm estimating the number of people whose average speed was 10 to 40, I would get 20 plus 120 gives me 140. Estimate the number of people whose average speed was 45 to 65. Why don't you pause the video, give it a go yourself, and see how you go. And assuming you've done all that, we will draw our bounds, our box here, to show where we've got. And in this case, we've got 3 rectangles to look at. The first one, rectangle 1. The width of it is going to be 5 because we're going from 45 to 50, and it's 5 times 6, so that's going to be 30. Next one is a width of 10. So a width of 10 between 50 and 60, and a height of 8, so it's 10 by 8 is 80. And finally, rectangle 3, we've got a width of 5 and a height, a frequency density of 5, so 5 times 5 is 25, and if I add those all together, I'm going to get 135 people in total. And this is just the basis of the things that you can get asked to do with histograms. Let's do one more, for good time's sake. But again, pause the video, try and do it yourself. When it asks, 100 farms produced 400 to 500 gallons of milk. How many produced 150 to 250 gallons? Okay, so what are we going to have to do? Well, we're looking at this as 100 farms, and what we can say is that we'll know that class width is 50 there. So we know that one of the bits to get the frequency of the area is going to be 50. Now, we know that 100 frequency in total, it says, is 100. So if that's 50 and the frequency is 100, then what we're 50 watts give me 100. So that frequency density must be 2. So that means each grid line up to there must be 4. So that's 4, 8, 12, 16. So we're being asked how many produced 150 to 250 gallons. So that's that one there. And we know the width of that is 100. So the difference between 150 and 250 is 100. So if that's 4, 8, then that part there must be, or we can guess it's roughly 10. So we'll have 100 times 10, which will give us 1,000 farms. Whoop-de-doo. So a bit of a reverse problem, but still using exactly the same principle. You're using the fact that area is the frequency is the area of each of these bits and bobs. What about 900 gallons produced up to 150 gallons? Estimate the number of gallons that produced 200 to 300. So up to that, and that bar is 900. So the frequency of this is going to be 900. So it's 150 times what gives me 900, and it's 150 times 6 gives me that. So the height must be 6 units. So we've got to use that to estimate the number that produced between 200 and 300, and we're going to have our 2 rectangles again for that. So we'll go 6, 12, 18, 24, finish labeling the histogram, and then we can work out our next bit, which is there. So the area of rectangle 1, just like we did before, we'll have a class width of 50, we'll have a height, if that's 12, that's 18, that must be 15. So we'll have 50 times 15, which is 750. And then the second one's 50 times 18, which is 900. And if we're estimating the number of people that produce between 200 and 300 gallons, then we get a total of 1650 farms. I hope that made some sense to you. If not, rewind back, bring your questions into class. That's histograms for you, and it's probably the toughest part of the statistics paper as far as maths is supposed to go. But much like every other type of graph and chart that you've got, it has its own set of rules and its own set of uses. And as long as you remember the key points of it, you should be okay. There's nothing really mind-blowing in histograms themselves, and we'll look at lots of past paper questions when we get home, or when we get into home. Feels like home at the moment. When we get into class. Okay, till then, I'll see you then. Bye.